Using a double pole breaker and running two hots with a common neutral and ground can be more efficient than pulling two separate circuits, as it reduces the number of conductors, wires, and connections required. Running one hot from each phase ensures that the load is balanced across the two phases, preventing overloading of one phase. The electrician's wiring method does comply with the National Electrical Code, or NEC. The term double-phased is not a standard electrical term, but it could be used to describe a circuit that utilizes two hot conductors from different phases. The electrician did run two dedicated circuits, although it is not a typical wiring method. This method is acceptable as long as the circuit is rated for 20 amps and protected by a double-pole 20-amp breaker, the conductors are properly sized and insulated for 20 amps, and the connections are tight and secure. This method should not be used for circuits that require high starting currents, such as motors or air conditioners. It is important to clearly communicate the intended use of the circuit to the electrician to ensure proper wiring. If there are any concerns about the wiring or its safety, it is always advisable to consult with a qualified electrician. This wiring configuration, using a shared neutral with a double pole breaker, leverages the properties of a multi-wire branch circuit. A multi-wire branch circuit, as defined by the National Electrical Code, or NEC, consists of two or more ungrounded conductors having a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit, which is connected to the neutral conductor of the supply system, and is identified as a branch circuit. In simpler terms, imagine a standard 120-volt circuit. Now picture two of these circuits originating from a single point in the electrical panel, sharing a neutral wire, and connected to a double pole breaker that provides 240 volts between the two hot wires. This configuration is what we're discussing. The key advantage here is the efficient use of conductors. Instead of running two separate sets of wires, you're effectively using one neutral wire for two circuits. This saves on materials, reduces conduit fill, and can simplify wiring in certain situations. Load balancing is another significant benefit. By connecting each hot wire to a different phase of the electrical supply, the load is distributed more evenly across the electrical system. This prevents one phase from being overloaded while the other is underutilized, which can improve overall system efficiency and stability. The NEC does permit multi-wire branch circuits under certain conditions. One of the most important requirements is that the circuit breaker must simultaneously disconnect both hot conductors. This is why a double pole breaker is essential. If one hot wire were to trip independently, the neutral wire could become overloaded, potentially creating a fire hazard. The simultaneous disconnect ensures that the entire circuit is energized in case of a fault. Proper conductor sizing is also crucial. The hot wires must be sized to handle the expected load, which in this case is 20 amps per circuit. The neutral wire must also be sized appropriately, although in some cases it may be possible to use a smaller neutral wire if the load is primarily nonlinear. Nonlinear loads, such as those produced by electronic devices, can generate harmonic currents that increase the current in the neutral wire. However, for typical residential loads, this is usually not a major concern. One of the main benefits is efficiency. By using a shared neutral, you reduce the amount of copper wiring required. This not only saves money on materials, but also reduces the weight and bulk of the wiring, making it easier to install and manage. Load balancing is another important advantage. By connecting each circuit to a different phase of the electrical supply, you distribute the load more evenly across the electrical system. This can help to prevent voltage drops and improve the overall stability of the electrical system. Cost savings also come into play with this method. Fewer wires translate to lower material costs. Labor costs can also be reduced, as it's often quicker to install a single multi-wire circuit than two separate circuits. However, it's important to note that the savings may not always be significant, and the potential risks must be carefully considered. There are some potential drawbacks to be aware of. If the neutral wire becomes disconnected, the voltage on the two circuits can become unbalanced, potentially damaging equipment. This is known as an open neutral condition, and it's a serious safety hazard. For this reason, it's essential to ensure that all connections are tight and secure and that the neutral wire is properly protected. Another potential issue is harmonic currents. As mentioned earlier, nonlinear loads can generate harmonic currents that increase the current in the neutral wire. If the neutral wire is not sized properly, it can overheat and potentially cause a fire. For this reason, it's important to consider the types of loads that will be connected to the circuit and to size the neutral wire accordingly. Consider the specific requirements of the home theater system. High-end audio equipment, for example, may be sensitive to voltage fluctuations. If the electrical system is not stable, it can affect the performance of the equipment. In some cases, it may be necessary to install a dedicated circuit with its own neutral wire to ensure optimal performance. Also, be aware of future expansion plans. If there's a possibility that the home theater system will be expanded in the future, it may be wise to install two separate circuits now, rather than trying to add them later. This will provide more flexibility and prevent the need for costly rewiring. Proper grounding is essential for any electrical circuit, and multi-wire branch circuits are no exception. The ground wire provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The ground wire must be properly sized and connected to the grounding system of the building. Also, be sure to use the correct type of wire for the application. In most residential wiring, non-metallic or NM cable is used. However, in some cases, it may be necessary to use metal-clad or MC cable or conduit for added protection. Be sure to check the local electrical codes to determine the appropriate type of wire for the specific installation. Consider the length of the circuit. The longer the circuit, the greater the voltage drop will be. Voltage drop can affect the performance of electrical equipment and can even damage it. For long circuits, it may be necessary to use a larger wire size to minimize voltage drop. Be aware of dirting factors. When multiple wires are run together in a conduit or cable, the ampacity of the wires must be derated. This is because the heat generated by the wires can build up, potentially causing them to overheat. The derating factors are specified in the NEC. When installing electrical wiring, it's essential to follow all applicable electrical codes. The NEC is the most widely used electrical code in the United States, but local codes may also apply. Be sure to check with the local authorities to determine which codes are in effect in your area. If you're not comfortable working with electricity, it's always best to hire a qualified electrician. Electricity can be dangerous, and it's important to take all necessary precautions to prevent electrical shock. A qualified electrician will have the knowledge and experience to install the wiring safely and correctly. Now let's get into more specific considerations when using a shared neutral for home theater circuits. When setting up a home theater, the goal is often to isolate equipment to minimize interference and ensure optimal performance. A shared neutral could, in certain situations, introduce noise or interference between the two circuits, potentially affecting sensitive audio or video equipment. This is more likely to be a concern with older equipment or systems that are particularly sensitive to electrical noise. With modern equipment designed with better filtering and isolation, this is much less of an issue. High-end audio and video equipment often require a stable and clean power supply to perform optimally. Voltage fluctuations or electrical noise can degrade the performance of this equipment, resulting in reduced audio fidelity or visual clarity. In such cases, dedicated circuits with separate neutrals might be preferable to ensure the highest level of performance. Consider the types of equipment that will be connected to the circuits. If the equipment includes devices with high inrush currents, such as power amplifiers, it's essential to ensure that the circuit can handle these currents without voltage drops. A shared neutral circuit, while capable of handling the combined load, might be more susceptible to voltage drops under heavy load conditions compared to two dedicated circuits. If the home theater system includes lighting, be aware that some lighting systems, especially those with dimmers, can generate electrical noise that could affect audio or video performance. In such cases, it may be best to put the lighting on a separate circuit from the audio and video equipment. Ensure that all connections are properly torqued to prevent loose connections, which can cause overheating and electrical hazards. Use a torque screwdriver to tighten the screws on the circuit breaker, receptacles, and other wiring devices to the manufacturer's specifications. If the electrical panel is located far from the home theater, voltage drop can be a concern. In such cases, it may be necessary to use a larger wire size to minimize voltage drop. Use a voltage drop calculator to determine the appropriate wire size for the length of the circuit. When running wires through walls or ceilings, be sure to protect them from physical damage. Use nail plates to protect wires that pass through studs or joists. Avoid running wires near sharp edges or sources of heat. Be sure to properly label all circuits in the electrical panel. This will make it easier to identify the circuits in the future and prevent confusion when working on the electrical system. Use a circuit directory to label the circuits clearly and accurately. If you're planning to install any new electrical equipment in the home theater, be sure to obtain the necessary permits from the local authorities. This will ensure that the work is done in accordance with all applicable codes and regulations. Before starting any electrical work, be sure to disconnect the power to the circuit at the electrical panel. Use a voltage tester to verify that the power is off before touching any wires. This will help to prevent electrical shock. Wear appropriate safety gear when working with electricity. This includes safety glasses, rubber gloves, and insulated tools. Avoid working on electrical systems in wet or damp conditions. Water is a good conductor of electricity, and working in wet conditions can increase the risk of electrical shock. Now let's delve deeper into the National Electrical Code, or NEC, requirements for multi-wire branch circuits. The NEC provides specific guidelines for the installation and use of these circuits to ensure safety and prevent electrical hazards. One of the most important NEC requirements for multi-wire branch circuits is that the circuit breaker must simultaneously disconnect all ungrounded conductors. This is typically achieved by using a double-pole breaker, which connects to both hot wires and trips both of them simultaneously in the event of an overload or short circuit. This requirement is intended to prevent the neutral wire from becoming overloaded if one of the hot wires trips independently. The NEC also requires that multi-wire branch circuits be identified at the point where they originate. This is typically done by labeling the circuit breaker with the words multi-wire branch circuit or some similar designation. This helps to prevent confusion and ensures that electricians working on the system are aware that the circuit is a multi-wire branch circuit. The NEC also specifies the requirements for the neutral conductor in multi-wire branch circuits. In general, the neutral conductor must be sized to carry the maximum unbalanced load on the circuit. The unbalanced load is the difference between the currents on the two hot wires. The NEC provides tables and calculations for determining the appropriate size of the neutral conductor. However, in some cases, the NEC permits the use of a smaller neutral conductor if the load is primarily nonlinear. Nonlinear loads, such as those produced by electronic devices, can generate harmonic currents that increase the current in the neutral wire. In such cases, the neutral conductor must be sized to carry the harmonic currents. The NEC also addresses the issue of open neutral conditions in multi-wire branch circuits. An open neutral condition occurs when the neutral wire becomes disconnected, which can cause the voltage on the two circuits to become unbalanced, potentially damaging equipment. To prevent open neutral conditions, the NEC requires that all connections be tight and secure and that the neutral wire be properly protected. The NEC also provides guidelines for the use of ground fault circuit interrupters, or GFCIs, in multi-wire branch circuits. A GFCI is a device that detects ground faults and interrupts the circuit to prevent electrical shock. The NEC requires GFCIs in certain locations such as bathrooms and kitchens where there is a high risk of electrical shock. When using GFCIs in multi-wire branch circuits, it's important to ensure that the GFCI is compatible with the circuit. Some GFCIs are not designed to work with multi-wire branch circuits, and using the wrong type of GFCI can cause it to malfunction. Another aspect of the NEC to consider is Article 210.4, which specifically addresses multi-wire branch circuits. This section outlines the requirements for the number of conductors, the type of overcurrent protection, and the identification of the circuit. It's essential to consult this article when designing or installing a multi-wire branch circuit to ensure compliance with the NEC. The 2023 NEC Handbook provides additional clarification and examples to help electricians understand and apply the code requirements correctly. The handbook is a valuable resource for anyone working with electrical systems. Furthermore, consider NEC Table 310.15b16, which provides ampacity ratings for conductors based on their insulation type and temperature rating. This table is essential for determining the appropriate wire size for the circuit to ensure that it can safely carry the expected load. Remember that the ampacity of a conductor can be affected by factors such as the number of conductors in a raceway, the ambient temperature, and the presence of other heat sources. Be sure to apply the appropriate derating factors as specified in the NEC. Also, it is crucial to ensure that the electrical panel is properly grounded. The grounding system provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The grounding system must be properly sized and installed in accordance with the NEC. Additionally, consider the use of surge protection devices, or SPDs, to protect sensitive electronic equipment from voltage surges. Voltage surges can damage or destroy electronic equipment, and SPD can help to prevent this damage. SPD are available in a variety of types and sizes, and it is important to select the appropriate SPD for the specific application.